In a similar way, there's some questions that give you multiple factors, multiple binomial factors, and you're asked to solve. So if you are looking at a problem like this, right, and you work through, right, again, you would multiply everything by the LCD. Well, you know that you need a factor, a binomial factor of y minus 6 as one factor, a binomial factor of y minus 2 for the second fraction. And then if you look at the factored form here, and most of these should be in such a form that the factors of positive 12 whose sum is negative 8 is minus 6 and minus 2. So those are the same ones. They're already repeated. So these two binomial factors are your LCD. So if we distribute that to each of the individual fractions here, the y minus 6's cancel, leaving our 6 times the remaining binomial y minus 2 minus the next fraction's numerator, the y minus 2's cancel here, so times y minus 6. And in this last term, both factors cancel, so you're just left with the numerator 8. So we've converted this from a rational form into a linear equation, which we can now solve. Distribute your 6 through, distribute your negative 2 through. And when you solve for this, you get 4y, the 12's cancel, is equal to 8. Divide by 4, you get y is equal to 2. And now, when we go back and look at that, and that's what this second part's for, what are the excluded values of y regardless of what the actual solution becomes? You know y can't be a 6 and y can't be a 2. Well, what did we get right here? We got a y equals 2. Can that happen? No. So what you would need to put is does not exist. And this means this is an extraneous solution. I mentioned this the other day, but I didn't give an example. An extraneous solution is a solution that comes about when you do the calculations, but when you plug it back into the original restrictions on the problem, it doesn't fit into that. Okay? So your answer for that one would be D and E. Now, most of the time you're probably going to get an answer, so I'm going to do a second example of this. Same idea, multiply by the LCD. Factors are binomial factor of q minus 14 and q minus 12. Here, your factors of this trinomial are minus 14 and q minus 12. So when you distribute through, you wind up with 14, your numerator, times the LCD factor that doesn't cancel, minus 12 times the LCD factor that doesn't cancel is all equal to 26. And so here, when you're working to solve this, again, if we calculate what we have, right? So you get 14 times the negative 12 is negative 168. So we get 14q minus 168 minus 12q plus 168 is equal to 26. So those are going to cancel. And we wind up with here 2q is equal to 26. Divide both sides, we get 13. So when we look at our answer, what are the two excluded values that we have to be aware of based on the domain restrictions? 14 and 12. This one does not fit into that, and so we would get our solution.